be restarting my computer at the first opportunity, but I would like to call the meeting to order. It is 7:31. So just in brief, we'll kick off with the officers' reports. As your president, I would like to let y'all know, thanks to Riyadh, the picnic is on, at least for now. Riyadh has reserved the shelter for us, and we are making plans to have a picnic in August this year, as safely as possible. Of course, if there's any grave changes in Michigan's overall trajectory between now and then, we will have to go virtual, but for the time being, we are hoping to have our first face-to-face event in August. Other than that, we are, of course, waiting on the word from our host institutions, Cranbrook and Macomb, before we can even think about rejoining in-person meetings anywhere else, particularly with the way that things are going in Michigan at this time, which is not good. So, Dr. Dale Parton, as your first vice president, has had a few health issues this week, and I'm not sure if he's going to be joining us, but he has a great lineup of future talks that you can see in the WASP, see a sneak preview. And I encourage y'all, if you are interested in giving a long talk, a short talk, or a news update to us, let Dale know. Email firstvp@warnastro.org and we can get you on the docket. We also have a speaker lined up for the banquet. Whatever form the banquet takes this year, we will be ready with an awesome talk. So, I'd like to hand things over to second vice president, Riyadh.
Thank you, Diane. Yeah, I visited the observatory a couple of weeks ago. Everything is in good shape. All the buildings, both buildings and all the equipment are fine. The one thing I need to mention also is that we did have a donation of a 12-inch Meade Schmidt-Cassegrain LX200 with a tripod and a number of eyepieces and a bunch of other attachments. So that's been added to the observatory equipment. Actually, it's in the shed. And that was donated to us by Dr. Brian Kerman, who I sent a thank you letter to with the itemized list of the stuff that he donated to us. So thanks to Dr. Kerman, we have a very nice 12-inch Schmidt-Cassegrain telescope, and hopefully we'll be able to set it up maybe one of these days and be able to test it out and use it. And that should be a good addition to the club equipment. Other than that, that's all I have for now. Thank you.
Very good, Riyadh. And I see that Dr. Dale Parton has joined us. Good to see you, Dale. Do you have anything you want to add in terms of an officer report?
Sure. At our next meeting on May the 3rd, Dale Hollenbaugh will have the main presentation entitled From Beginner to Journeyman, My Journey in Astrophotography. The short presentation will be given by Jenny Callahan, who's working on a doctorate in astronomy at the University of Michigan. Her presentation will be on the temperature profile of a protoplanetary disk. Then a month from now, on May the 20th, Gillen Brown will be our speaker. He's also working on his doctorate at the U of M. His topic will be the origin of the elements. And finally, I'd like to say I need speakers. The next vacancies or openings that I have are in July, both the first and the second meeting in July. So if anyone would like to talk about contributing something, please let me know. Thank you. Diane, back to you.
All right. Thank you, Dale. And let's pass things over to Adrian at Treasury.
All right. I am looking at balances as we speak, and good news is that we've had a couple of more membership updates. Looks like Dale, you updated yourself. So we're currently sitting in our main checking account at $22,672.40. Our GLAC account, $3,279.84. No movement there. And reimbursements, I think, have been pretty much handed out through from GLAC to those that spent. A quick reminder for it's kind of for you, Jonathan, and anyone else who has expended money on behalf of the club. I have a couple of different ways to process reimbursements. All I need is a copy of a receipt, a picture on your smartphone of your receipt will do, so that I have it for records, and then I can process reimbursements pretty easily. We have built up our PayPal account, and we are now sitting at, as soon as this comes in, we're sitting at $1,135.40 in our PayPal account. So that makes it easier to have kind of virtual liquid cash to move around. Our real cash, because of our pandemic and everything hasn't, none of that is moved. I've tested and properly used this little thing, which you can't see because my virtual screen. Our ability to accept money into our PayPal account using this little device works and works very well. Once we're in person in 2022, or maybe by this summer, we'll have to see what happens with vaccinations, and then case counts. It'll be easy for us to take card payments directly to PayPal. So we've been growing this PayPal account slowly but surely, and I will be using it for reimbursements, club business. We don't have to dig into our personal account as much, or our business account as much. And as far as memberships goes, latest update, we are still at 173. I think that's a few more. I thought it would be a little higher. We had a couple of renewals, but they had already been put into the spreadsheet. So based on that, if the records are updated correctly, we are at 173 paid memberships. And we encourage all those who may not have paid membership for a while to consider sending in your dues. There's certainly time. Dues coming in for this year will apply until 31st of December, and then we'll start all over again. But so far, Treasury looks good. The accounts are looking good right now, and as of yet, there has been no attempt to migrate GLAC out of our care into its own account. That's still sort of up in the air, but GLAC, to be honest, we haven't been as busy. We're still looking to decide if we're going to go virtual, and from the looks of it, we are probably going to move ahead with a virtual astronomy at the beach again, because we do not know that the state is going to be ready for us to do something physical by the time September rolls around. So because of that, our GLAC funds are still in the hands of the WAS, and we'll just leave them there for now. Any questions, Jim? As soon as you go off mute, I'll be able to hear you. Jim, you're on mute. Jim, you're still on mute.
Jim, why don't you type the question in the chat?
Yeah.
Okay.
There we go.
To what do we assign the, looks like about a 50% increase in membership too?
I think it's there's been a huge increase in people wanting to know the night sky. One of the things that has proven to be COVID proof over the last year are people getting out and doing things outside. And the night sky is one of those things that always naturally intrigues people. I attribute it just to the simple fact that with nothing else to do or nothing else that's safe amongst people, being outside is now a bigger draw. Nature is a bigger draw, and the night sky has become intriguing to people who would otherwise, not pay too much attention to it, just because they're too busy doing other things and being social. Well, you pull that away and you've got, well, this night sky thing's kind of fascinating. Let's check that out. So I think that's where our growth in membership, astronomy clubs across the board.
Well, that's really good news. But we for 20 years we've had a membership around 100 or a little just over, and that big increase may have to do with a more efficient way of taking memberships virtually or something like that. Just a
It
question.
helps, but to be honest, I got a lot of checks. So people were we have 252 people that were at one time members or are current members of the WAS. So I got a lot of renewals, and maybe I would count over the last couple months 5 new memberships that came in. So
Good.
people are getting re-energized about science and about the stars.
We also sent a renewal mailer
Yeah.
this year for the first time in several years.
Well, they
So
paid
that probably didn't
attention
hurt.
to it this time.
I think the virtual meetings helped as well.
Yeah, we certainly have David Levy as an example of someone who can interface with us. He's not the only one who can, at the comfort of your own home, you can now attend a WAS meeting and learn with what we're doing. I think Catherine just put something in chat that I'll check out. Yeah. So we're happy any way that we're getting our new membership. We're happy that you all are aboard.
Doing something right. Let's keep doing it.
Yeah. Until we can do we have had a lot of, and then I'll be done with my report, but I do want to add to it. We've had a lot of people ask about, can you show us the night sky? Can we look at your telescope? Can we do a private showing at the observatory and things like that? We've had to turn them down, but we also tell them, here are some resources so that you can follow up on your interest of the night sky. We've had a lot more people, like I said, that just are more interested. There's more to do. And Jim, I'll get with you later because I want to attend the McMath-Hulbert meeting. I'm a member there and I need to attend my first meeting. So that doesn't have to go in the minutes. This has been your treasurer's report. Thank you all. And back to you, our esteemed president, Diane. If you stop spinning.
Victor, question?
Yeah. Is that card reader, does that plug into the headphone jack? Okay.
Yes, it does.
Yeah.
I've
Nowadays,
tested it.
Nowadays, okay. Nowadays, they're making cell phones without the headphone jack. So
Yeah, so
that was
the
questionable.
device I'm using happens to be an older iPad device, perfect with an old headphone jack, and it works perfectly through there. So needless to say, I won't be turning in this iPad anytime soon.
Okay, that's good. All right, cool. Thanks.
Yep.
All right. Let's. Oh, is Mark here? Yes. Secretary.
Good evening, everyone. Just have to report. This will be a real long one. I have nothing to report. Back to you, Diane.
I should mention that I have the key for the post office and I visited recently.
That was really long.
So I've taken some of Mark Kedzier's work off of his hands. So that's part of it.
Diane, you're buffering.
Then
I was hoping it wasn't.
We can't hear her.
Yeah, it's just buffering again.
Yeah.
Oh, she's back.
Can we hear her?
Dale Teamy, Publications.
Okay, well, the WASP is up for April, and May is well underway. I'd like to remind contributors to get their articles and reports going, as April is halfway through already. So back to you, Diane.
All right, thank you. And I will ask Dr. Dale Parton, since he's here now, to take over for the special interest groups while I take care of my technical issues. Thank you.
Dale, unmute yourself.
Sorry about that. I see Riyadh. Riyadh, do you have a special report for us?
Yeah, I already gave that, I think, while you were signing in. You're talking
Okay.
about the new donation?
Measuring things in the sky.
Oh, I'm sorry. No, unfortunately, at this time, I don't have a report on that.
Yeah, I'm sorry, everyone. I signed in a little late. I just got back from Dearborn. I had to go there to get the second COVID shot, and I just barely made it back for the meeting. Let me think. Is Marty Kunst here? I don't see him. Anyone want to comment on what the sun is doing?
Yeah, there's one spot that's been rotating across today or this week.
Okay.
Spot 2814. In case anyone wants to know the sunspot number.
Let no sunspot go unnoticed, right? Dale Teamy, do you have a history report of any kind?
Yeah, just today, this is breaking news. We just discovered a new trove of old WASP issues, care of Dave Harrington, a former longtime member. And he was cleaning out his basement and offered them up to us, and they've been collected and should be on their way to me by the weekend. So I'm looking forward to possibly getting some more scans in.
So these may include issues you didn't have before?
Fingers crossed, yeah.
How many issues would you guess you're missing?
It's only a handful now. In the years that he says he got issues for, is probably in the single digits. So it's kind of scary, hopeful that we will hit some winners there. And it's been reported to me that we've had some months where the issue simply did not show up, but I only found 2 references in the WAS that admitted to missing a month. So hopefully we've cleaned that up, and the rest of the issues will surface, and we'll get some copies of scan.
I mean, for those who haven't been a member of the society very long, Dale has been tracking down all the issues ever published of the WASP, our monthly newsletter, scanning them, cleaning them up, I think for some old ones to make them more readable.
Yeah.
And then publishing them online, right?
Yep. They're all on our website that I've been able to do.
So what year did the WASP have its first publication?
That'd be March of '69.
Okay. Diane, are you with us now?
I sure hope so.
Okay. How about I turn it back to you?
Sure. Sounds like we just got done with the history subgroup.
Yes.
Yes, we did.
Okay. Has astrophotography gotten to go?
Yes.
I do. I have an image here to show that I took last month up here at the observatory. This is the Sombrero Galaxy, Messier 104. This is 7.5 hours of integration time from up here. This is an interesting object because this is pretty visible in anybody that's got an 8-inch or larger telescope. I mean, you can't see this kind of detail with an 8-inch, but if you get a larger telescope, you can see the dust lanes around here. This galaxy is 31 million light years away, and the bulge obviously makes it look like a sombrero. And the astronomers claim that this is due to 2 galaxies colliding into one. And apparently this dust that's all through here that surrounds the inner core used to be surrounding the entire bulge, and over billions of years, finally turned into one dust lane around the entire perimeter. So if you have a chance to get out in some dark skies, you don't even need really dark skies with your 8-inch or bigger telescope. I recommend M104. It's in the constellation Virgo, so it'll be pretty visible in the coming months. That's all I have right now. Back to you, Diane. Thank you.
All right. Thank you, Bill. Okay. Astronomical League.
Nothing too much to report. We are coming up on the renewal date, so if you renewed your membership and send in your $750, we'll get you renewed for next year.
Sounds good. Thank you, Jonathan. And that concludes our subgroup reports. Let's have observing reports. I see David Levy's both hands up. David, you first.
Thank you. Thank you so much. The only observing report I have, I will be going out to see if I can spot that little sunspot in a few minutes. But I have been trying to spot the new comet Atlas over the last few nights. Actually, it's not so new. It's 2020 R4, so it's not so new, but it's supposed to be about 10th magnitude. I have not been able to find it as try as I might, but I'm still going to continue to try it in the hope. One of the interesting things about this comet is that a few nights ago it was almost exactly in the same position that my first comet was when I discovered it in 1984. So I thought that would be a good memory, but it's gone on now, and I'll try it again if it should clear tonight. Anyway, for my poetry quote of the meeting, speaking of comets, I'm going to quote from Leslie Peltzer's Starlight Nights, where he just talked about the 12 comets that he discovered. He writes, I had watched a dozen comets, hitherto unknown, slowly creep across the sky as each one signed its sweeping flourish in the guest book of the sun. What a way he had of writing and talking about comets, second to none. And on that, I will give it back to you, Diane. Thank you.
Thank you, David. All right. Got some more observing reports there. As David said, there are some sunspots. There's it's galaxy season. Anybody got something to share? You can throw a stack in the chat if you want me to call on you and you're afraid I can't see your hand. Nobody?
So I have of course, an observing report, but
all right,
this tablet that I'm using, unfortunately, I do not know how well the image will show up. I hope to show the image. So if I start to break up, you'll have to forgive my crappy tablet. Hopefully the picture found its way here, so I should be able to. I'll see if I can share, and there we go, photos, and I got to be careful and pick the one of these. I'll share this. I'll just share this one because it's basically appears to me the zodiacal light hasn't gone anywhere. It's a little fainter, but that does appear to be the telltale sign of zodiacal light. It's on an angle. It's along the ecliptic. You have Orion here to your left that shows you it's a little bit below, or Orion is around and near the ecliptic. And so there's the winter Milky Way, and that is Lake Huron. I'm at Point O'Bark Lighthouse. I was taught the proper way to pronounce that recently. This is turned away from the lighthouse and looking at the park, or looking back towards more like the northwest. And that's one of the images that I took. I actually went out there to see if I could pick off the 37 cluster. I decided I'd go for a small, let's see if I can stop sharing somewhere here. Yeah, I went for the 37 cluster because I figured, why not? That's a nice little image to pick up and see if I can get something something of interest other than just the night sky images. And as it turns out, I pointed, and there you see in the bottom, a little bit of the bottom to the left a little, is the 37 cluster. I think it's NGC 2169. Xi Orionis is the brighter of the stars to the upper left, and Nu Orionis is the brighter star to the right. And there's the 37 cluster. There are hundreds of stars in this cluster, but being that I didn't even use a telescope, I used a Canon 6D and a 300 millimeter lens to aim at this and do a 90-second exposure. My stars aren't as sharp, but this was sort of a proof of concept. Could I get a star cluster with my camera equipment? And so I've got a couple of modifications that I would do. Doug raised his hand. Doug Bach, you had a question.
No, just getting in line.
Okay. Yeah, darn. I thought the great Doug Bach would have a question about my image. He does not. Well, there, I've zoomed it in a little bit. It looks eerily like a 37. And Jonathan, are you getting in line too, or you have an actual question? I think he's getting in line. So at any rate, that's those are probably the two big things with my observing report. I took the chance to leave to go out to Point O'Bark when I saw that it was going to be dark and it was night after new moon. I didn't want to miss it. I think I had gotten vaccinated that day, so why not drive out at night and go image something? Yeah, the vaccines effects didn't feel them as much. I don't know if that has anything to do with youth, luck, or tomorrow I'm really gonna get hit. I'll find out, but so far so good. And as I began to just start telling people, always look up at the night sky when the clouds break. You never know what you'll find. So that's my observing report.
Thank you, Adrian. All right, let's pass things to the great Doug Bach to see what's going on at the NCO.
You guys are delusional. Just wanted to share one thing. We talked about, or David Lee was talking about the other comet R4, which I failed to gather on the last clear morning due to technical issues. But that same night, I also picked up 2020 T2 Palomar with the 10-inch. This is basically 10-minute exposures. Integrated exposure. Plus, there's some galaxies in that field of view. So that's my observing report for this session. Something out of a little bit out of the ordinary, not the usual galaxy stuff. I've got plenty of that, but that's for some other time. So there's my observing report. Comet C/2020 T2, otherwise Comet Palomar.
Does that look
Excellent.
like it has a little bit of a tail to pointing down?
Yes, it does a little bit.
Okay, all right.
And I tried to go after R4 the next morning, and it was cloudy here. So I'm still waiting for a clear morning around 3 o'clock. I should be able to pick it up as it rises above the wall of the observatory. So, but David should be able to pick it up pretty easy. He's further south, and he probably is wide open skies to the northeast.
All right.
Okay.
Excellent. And
So-
Jonathan.
Go ahead, Jonathan. I was going to say,
Well,
Doug,
go
anybody
ahead.
that knows you, Doug, you do comments a lot, so it's not out of the ordinary for you.
I think they're fun. They're fun to track and follow, and I've done time lapses of them as well as asteroids. So I find them interesting because they are transients, as opposed to galaxies are cool, but transients are fun. Okay, Jonathan, go ahead.
Around here. Well, if you want to talk about transients, so I would say that Adrian is not the only person who is seeing cool atmospheric effects, which is, of course, planetary observation. But I saw a really nice solar halo with a circumzenithal arc a couple weeks ago, and that's usually more of a winter thing. So it was a beautiful day. I'm not sure what caused it. I mean, high ice crystals, but it really wasn't the right kind of weather for it. But that was a really cool thing. So whenever you see sundogs on the left and right of the sun, and you kind of see that they're starting to spread into a circle, it always happens to me on the road, but try to find some place to pull over and look up at the top of the sky, and sometimes you'll see an upside down rainbow there. So it's a pretty cool thing to see.
All right.
Agreed.
Anyone else for observing? If not, going once, going twice, I can pass things to Ken Burton, who is tonight's In the News in the Sky presenter. You ready, Ken? I think you're on mute, Ken.
I'm good now. Let me see. I've got to share here.
Yep.
I think that's where we're going to be. And let's do this right now. Here we go. Got something special for you here as it comes up. How's that?
Ooh,
Pretty good.
That's from a guy by the name of Alan Friedman, who was in Buffalo, New York. And he took this picture, obviously, of the ISS going across the surface of the sun. Thought that was pretty cool to do. But let's get to the regular in the news. This is in the news in the sky for 4/15/2021. For the first time, scientists have detected X-rays being emitted by the planet Uranus. The discovery was made by a new analysis of data from NASA's Chandra X-ray Observatory. Planet Uranus is surrounded by thin rings. This world rotates on its side with respect to the plane of our solar system. This composite image is composed of both X-ray and visible light images. The X-ray emissions appear here in pink and the visible light as blue. The image, again, is from Chandra X-ray Observatory. Let's go to the next one. There you go. Many objects in space emit X-rays, including black holes, neutron stars, and special class of binary stars known as X-ray binaries, exploding stars called supernovae, and the remnants, and our own sun. Most of the planets in our solar system, and even some of Jupiter's moons, are known to give off X-rays. But until now, when astronomers looked at X-rays from the ice giant worlds of Uranus and Neptune, they found nothing. Now, for the first time, astronomers have used Chandra to detect the X-rays coming from one of the ice giants, Uranus. Some of the other planets in our solar system, including Earth, Uranus including Earth, has auroras in its atmospheres. These may be one source of the X-rays seen by Chandra. These photos are composites of images from the Hubble Space Telescope and Voyager 2. Moving on, this is again another one of the shots of something from Jupiter. This is where Juno has found a new auroral feature on Jupiter. This was on April 7th. And NASA's Juno spacecraft's mission in orbit around Jupiter was recently extended to 2025, has been used to discover rapidly expanding auroral ring at the very fringes of the Jovian magnetosphere. NASA said in this Hubble telescope picture, a certain glowing glass is wrapped around Jupiter's north pole like a lasso. And this curtain of light, called the aurora, is produced when high energy electrons race along the planet's magnetic field. Jupiter's expanding rings are about 1,200 miles across, and they race outward at speeds of approximately 3 miles per second. Juno's ultraviolet spectrograph took images of the faint aurora features, likely triggered by the charged particles coming from the edge of Jupiter's massive magnetic sphere. The false color series of images are 30 seconds apart, those are the red panels, and display ring-like emissions that expand rapidly over time. This illustration shows the auroral oval in Jupiter's ultraviolet wavelengths. Closest extragalactic fast radio burst on April the 8th. It's the largest one, the closest extragalactic fast radio burst so far. Astronomers detected a new nearby repeating fast radio burst originating from a spot near the Great Spiral Galaxy, M81. The galaxy on the top right is M81. The square insert in the top left shows the extent of hydrogen gas surrounding this galaxy. The red oval indicates the region of origin for the fast radio burst, to a likelihood of about 90%. These astronomers said within this region there are 4 known entities that could have spawned the burst: ionized gas region, an X-ray source, a globular cluster, and a radio source. This image, the FRBs, is practically in our own backyard. We can study the FRB source in great detail at various wavelengths. Therefore, it shows great promise in testing different progenitor models. There is also a chance that the FRB came from even closer, from the outskirts of our Milky Way. One such was detected in April of 2020. The way to measure how far away they are is to see how much the signal is spread out. The farther away from us as the signal comes, the more interaction it has with electrons along the way that causes it to smear out. It's worth noting that the FRB source could be a solitary neutron star wandering in far reaches of the Milky Way halo. In that case, the FRB source would be extremely energetic and possibly the farthest Milky Way neutron star ever discovered. Astronomers pinpointed the neighborhood of the nearby spiral galaxy M81. That is nearby in astronomical terms is 12 million light years from us as the most likely host. However, although M81 is somewhat different from other galaxies where FRBs have been found, for example, the region of the FRB is farther away from the galaxy than expected. The region where the FRB seems to originate harbors at least 4 known objects. They are one region of ionized gas, 1 globular cluster, 1 X-ray source, and 1 radio source. There are reasons for each of these being the possible source of repeating FRB, and the astronomers are calling for follow-up observations to learn more. The fast radio bursts were discovered using the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, radio telescope in British Columbia. And this image is via Andre Renard. Hubble spots double quasars in mid-merging galaxy. This is an April 11th report. Astronomers said on April the 6th, 2021, that they're spotted two rare double quasars. Each pair is thought to reside in the midst of two merging galaxies in the very distant universe. Astronomers estimate that only one in 1,000 quasars is double. So finding two double quasars could be seen as lucky. The astronomers would tell you, though, they didn't use luck. They used a series of telescopes that led them from one step to the next, in a methodical unraveling of the mystery of which bright, apparently single quasars might actually be double. As lead researcher Yu Shen of the University of Illinois in Urbana-Champaign put it, finding these double quasars is like finding a needle in a haystack. Collaboration between scientists and some of the best telescopes in the world led to new images of the double quasars. The study was published on April 1st in the peer-reviewed journal Nature Astronomy. Each of the newly discovered pairs of quasars, or 4 total quasars, were discovered within 10,000 light years of their mate. That's very close on a cosmic scale. By comparison, the sun is about 26,000 light years from the supermassive black hole at the center of our Milky Way galaxy. This artist's conception shows two blazingly bright quasars and the emerging galaxies in which they reside. Both quasars have supermassive black holes at their cores. A new study suggests as the two galaxies merge and the quasars get closer together, the two black holes will merge to form an even more massive black hole. A small asteroid passed very close to us on April the 12th. Asteroid 2021 GW4 was discovered on April the 8th using the 59-inch telescope of the Catalina Sky Survey at Mount Lemmon, Arizona. Small asteroid 2021 GW passed extremely close to the Earth, passed at 12,313 miles from the Earth's surface, or about 5% of the Earth-Moon distance. The location of this asteroid 2021 GW4 with respect to the constellation of Leo the Lion on the night of Sunday, the April 11th, as seen from the U.S. Spacecraft again traveling at 18,000 miles per hour, or 8.36 kilometers per second relative to the Earth. The closest approach of the asteroid again occurred at 1300 Universal Time on Monday, April the 12th. Raindrop size is similar to the Earth on an alien worlds. Whether a raindrop is made of water on Earth, methane on Titan, liquid iron on an alien world, a new study shows that all raindrops will fall to the ground at a similar size. Earth has raindrops of water, while on Venus the rain is made of sulfuric acid. Jupiter rains droplets of helium. Saturn's moon Titan rains methane. On Neptune and the other gas giants, a diamond rain may fall. And in the case of the exoplanet WASP 76b, raindrops are thought to be made of superheated liquid iron. But there's one thing all these different types of raindrops might have in common: their size. A new study led by Caitlin Loftus of Harvard University has announced on April the 5th, and it suggests that on whether planet or moon rain falls, that particular world's atmospheric and gravitational constraints keep raindrop sizes within a range that's common among worlds. Loftus commented there's a fairly small range of stable sizes at which different composition raindrops can happen. They're all fundamentally limited to around the same maximum size. Well, there's possible life signs in the clouds of Venus. April the 13th, 2021 report, new analysis of data from the 1978 Pioneer Venus mission by researchers at Cal Poly Pomona finds evidence not only for phosphine, or phosphine, I guess it is, but also possible chemical disequilibrium in Venus's atmosphere, an additional possible sign of biological activity. In late 2020, scientists studying the atmosphere Venus announced the surprising and controversial study of phosphine, a chemical that on Earth is produced primarily by living organisms. Jane Greaves of Cardiff University in Wales and her colleagues asked at the time, could the phosphine be a sign of microorganisms inhabiting the Venus's atmosphere? Well, maybe, other astronomers said, scientists said, but phosphine itself wouldn't be proof of life. And subsequent studies questioned whether the phosphine was ever there at all. Then on March of 2021, a study from Rakesh Malgal of Cal Poly Pomona supported the original finding of phosphine and went farther. He suggested other biologically relevant chemicals in Venus's atmosphere that appear to be in a state of disequilibrium, another hallmark of life. Here's an artist's conception, an artist's illustration depicting molecules of phosphine in Venus's atmosphere. On Earth, as far as scientists know, there are only two ways to produce phosphine, either artificially in labs or via living microbes. The temperate zone of Venus's atmosphere, where temperatures and pressures are more habitable life. This is an image via Seeger et al. In 2020. Of course, scientists believe that Venus was once much more Earth-like, with rain, lakes, and even oceans. Did it ever have surface life is the question. Mars helicopter's first flight has been postponed to next week. This is an April 13th report. The Mars helicopter, named Ingenuity, now needs a software update, NASA said, and the new first flight will be somewhat next week at the earliest. It's going to diagnose the issue of developing potential solutions. It's develop, validate, and upload software, load flight software into flight controllers, boot Ingenuity on new flight software. So that's the new material that's going in. Ingenuity flight is successful. It will be the first powered guided flight on another planet, expected to follow a handful of other test flights over the month-long campaign that aims to show that aerial exploration is feasible in Mars' thin atmosphere. JPL wrote in a tweet posted earlier in the day on April the 8th, mind-boggling, isn't it? Mind-boggling, too. The blades of glory, aka rotor blades of the Mars helicopter, have been unlocked and are ready for testing. Next, we'll do a slow-speed spin-off blades for the first time in the Martian surface. Ingenuity has also snapped its first color photograph on April the 3rd, shortly after being lowered into the Martian dirt by the Perseverance rover. This image shows the floor of Mars' 28-mile wide, 45-kilometer Jezero crater and a portion of two wheels of the NASA's Perseverance Mars rover. This low-resolution view of the floor of the crater and a portion of the two wheels was captured by the agency Ingenuity Mars helicopter. As I said, it's the first color photograph taken by Ingenuity on the Martian surface. As a chemical fingerprint reveals a migrating exoplanet from April the 14th. Chemical fingerprint of exoplanet HD 29458b atmosphere. It reveals as many as 6 molecules that it has migrated inwards from its birthplace much further out in the solar system. An international team of astronomers analyzed the light of the exoplanet, also known as OSIRIS, and found as many as those 6 molecules in its atmosphere. The most molecules ever detected in a planetary atmosphere outside of our solar system, according to an announcement of the University of Warwick in the United Kingdom on April the 7th. There's a Martian hill now named for the honor of the Curiosity scientists. NASA has given the name Rafael Navarro Mountain to a hill in Gale crater on Mars, where the Curiosity rover has been exploring since 2012. Navarro, a mission scientist, died on January the 2021 from COVID-19. There's a lot of focus this month on this NASA's new rover on Mars, Perseverance, and its adorable sidekick, Ingenuity, whose first flight has now been postponed. In the meantime, the Curiosity rover, which has been on Mars again since 2012, is still busy exploring the mazes and buttes at the base of Mount Sharp in Gale Crater. And there's news that the Curiosity mission that strikes closer to home on April the 5th, NASA announced that a crabby hump of Mark Sharp has been named for Rafael Navarro. So another layer in its core. This is a report that actually came out today. Scientists have found another layer in its core. Researchers from the Australian National Observatory of Geophysics, led by Joanne Stevenson, confirmed the existence of what they're calling the Earth's innermost inner core. We found evidence that may indicate a change in the structure of iron, which suggests perhaps two separate cooling events in Earth's history. There's more on this study coming later. And telescopes unite in an unprecedented observation of a famous black hole. This is an April 14th report from Harvard-Smithsonian Center for Astrophysics. In April of 2019, scientists released the first image of a black hole in galaxy M87 using the Event Horizon telescope. However, that remarkable achievement was just the beginning of the science story to be told. Data from 19 observatories released today promise to give unparalleled insight into this black hole and the system it powers, and to improve tests of Einstein's general theory of relativity. And that's the end of In the News. But in the sky, I've just got a couple of reports here. First of all, April the 22nd, 2021, you'll find Hercules between two bright stars. Try locating one of the coolest constellations up there. The constellation Hercules, the kneeling giant, can be seen ascending in the east-northeast on these northern hemisphere spring evenings. You can find Hercules between the two brilliant stars Arcturus and Vega. The chart at the top of this post shows the sky at around 8 to 9 p.m. Daylight savings time, when the constellation Hercules and the two stars so essential for finding it are well up in the northeastern sky. Arcturus is in the constellation of Bootes, and of course Vega is in the constellation of Lyra. At nightfall, Vega may still be below the horizon, so just wait a while and it'll rise pretty soon. The line between Arcturus and Vega passes through what is known as the keystone, an asterism or notable pattern in Hercules. Keystone is a squarish figure in the center of Hercules. Up for a big observation challenge. Try to spot the planets Mercury and Venus coupling up on the sky's dome in the dusk of April the 24th through the 26th. We give you fair warning, the quest won't be easy, even with binoculars. You'll need an unobstructed horizon, view of the horizon in the direction of sunset and a crystal clear skies to view these close-knit worlds in the glow of the evening twilight. The real sky will appear brighter than it does in our sky chart, and you'll probably won't see the constellation Orion until after Mercury and Venus have set. April full moon is the year's first supermoon, apparently. Around the world, the moon will look full to the eye on the nights of the 26th and 27th. However, the crest of the full moon will fall on April the 27th at 3:31 Universal Time. At United States time zone, that translates to April 26th at 11:31 p.m. Eastern Time, 10:31 Central Time. In North America, we call the April full moon the pink moon. This April full moon represents the first in a season of 3 straight full moon supermoons. Overall, this April full moon gives us the second closest full moon of the year. And at Eta Aquilid, meteor showers picks up steam over these next several mornings, May 3rd through the 5th, watching the waning moon to flit by the ring planet Saturn and then the giant planet Jupiter. On May 3rd, the moon passes due south of Saturn to stage a conjunction only a few hours before the moon reaches its high illuminated last quarter phase. A little over 1 day after the moon-Saturn conjunction, the moon will sweep due south of Jupiter. And you should read all you need to know. Eta Aquilids, they're not very active, but they're something to look at. And that takes care of In the News and In the Sky for 4/15/2021. Any questions?
All right, thank you, Ken. It is 8:26. Let us take a 14-minute bio break and reconvene at 8:40, not 8:30, 8:40. So feel free to grab your snack, grab your drink. See you in 14 minutes, gang.
A lot of good stuff today.
Yeah, there's a lot. I'm surprised I haven't missed the flight of Ingenuity, but I guess I haven't yet.
Well, they've got, like I said, 4 or 5 things they've got to solve right now in order for that to go, and that's the issue with it. It's not a it's not an easy, this is not an easy one actually, and that's the deal, and I've gotten a lot of feedback from several of my friends. By the way, if you watched the show Jeopardy, the final question was about what constellation is involved with the weapon of the subject of the thing has a nebula in it, and it was the final question. And 3 of the people, 2 of them answered Sagittarius. After one of them had answered Orion, decided that wasn't right and went to Sagittarius. And the one who won the whole thing, of course, answered Orion. It took me 3 seconds to do, as they said, but I said, boy, why couldn't
Wait, what was the question? Which constellation hold the weapon?
What it has a nebula and a weapon.
Has a nebula and a weapon.
In the weapon.
In the weapon. Okay, yeah.
There you go. It's in the sword, right?
Yep.
So anyway, so I went, oh, damn. It's like that one with Who Wants to Be a Millionaire, with a $500,000 question was about syzygy. Oh, my goodness gracious, to be there at the time,
So Ken, in your in the news thing,
yes,
where the Juno probe around Jupiter showed an aurora, I was interested in the photo where you saw pretty much the whole sphere of the planet, but the aurora was offset, and I'm guessing that is due to the tilt of the axis with respect to the plane. Is that correct?
Here's your answer. Are you ready for this?
Okay.
There are actually 3 poles on Jupiter.
3?
There are 3. There's one at the north, one at the south, and one in the middle of the planet. And the magnetic field jumps out from that area. So yes, you could have aurora much lower than you would suspect on the Earth and such, or between the poles. So the magnetic field of Jupiter is so immense, it also has 3 points of origin, believe it or not. 3 poles. They're magnetic poles is what we're talking about, obviously.
So it is a magnetic pole is what that is centered around.
That is exactly what it is.
Not necessarily the actual tilt with respect to the ecliptic?
Correct.
All right.
Not a problem. Not an issue with that at all. The only planet that really has a radical tilt is Uranus. Uranus is 98 degrees tilt. All the rest of the planets are pretty much up and down. We have a pretty radical tilt ourselves, but of course that was produced by, I guess, the planet that ran into us that produced our moon, tilted us over. But the rest of the planets, exclusive of Uranus, are pretty much, straight up and down directly to the ecliptic. So that's an interesting point. But when I just learned about this 3rd magnetic pole on Jupiter about a year ago, and I went, huh? And it's one of the reasons is the magnetic poles of Jupiter, that the magnetic field of Jupiter is substantially larger than the sun. So you're talking about we're talking we also talked about sending humans to the moons of Jupiter, which is really a very bad idea, because it irradiates those moons to a point which would be fatal to a human being. Even the Juno going around it is like a tank in comparison to protect it from the radiant energy of the planet itself. Jupiter is not a good place to go. All right, and even the only planet The only moon that you could go to Jupiter that a significant moon rather would be Callisto, because it's so very far from the planet. But even there, you would still have a radiant effect. So there you go. And I'm almost embarrassed I know this stuff. No, I'm not.
Well, not excessive. I was going to say excessive. That's not the right term. An impressive amount
thank you.
About Jupiter and Saturn, especially.
Well, it has been, astronomy is in my hobby since I was 6 years old, and I'll be 75 at the end of May. So I've been studying an awful long time. And Alan Kaplan will tell you, for example, that I was a pest when I was a guy in high school with astronomy. Used to drive everybody crazy. My teachers used to say, "You know too much about it," but you're bombarded with it, and every chance I get, I look at what's new in astronomy. I've been doing that for 40 years, and it's amazing what comes out, and they just keep finding more stuff. It's great stuff. The funny thing that happened was I was talking to Fred Espenak on something. We were talking about that this Jeopardy question was that question, and somebody asked me a couple of things about it, and Fred says to me, "It's really amazing to me that," he says to me, "that these three brilliant people on Jeopardy, two of them did not know about that, that it was Orion." And I said, we have a lot of work to do to teach, don't we, about astronomy. People just don't know, so.
Speaking of Jupiter.
Yes.
I'm going to share an image here.
Cool. I'm good.
So this is one of my best images of Jupiter.
That's magnificent.
But recently, I got a new piece of software that uses algorithms to sharpen stuff.
Okay.
And I ran it through the software and tweaked it a bit.
Uh-huh.
And managed to get that.
It's just magnificent. What a great shot.
See, I mean, that's very impressive.
That is, it is
how much it sharpened
impressive.
it up, didn't it?
Look at that thing. Isn't that
Topaz
wonderful?
Sharpen AI?
Topaz Sharpen AI. I got the bundle. I had the bundle on sale. The denoise, I really like. The Sharpen, yeah, it's a hit and miss. This was a hit. Some of the other ones, it didn't do that much. But,
yeah, I'm just using the denoise, and I'm thinking maybe I should have done the bundle, because I figured most of all my night shots out there in the wild are noisy. So
noisy.
I mostly needed that.
Night shots, yeah. I would say that the denoise is worth every penny. The Sharpen can help. It's not as it can help actually in regular terrestrial photography for slight motion blur and out of focus. It has some of my bird stuff. It's sharpened up some stuff.
Yeah,
but
lower light.
The two other pieces of software that came with the bundle were less impressive. Gigapixel, it makes things bigger, more resolution. But yeah, it's.
What's kind of remarkable about this picture? What I really like about it, that Jupiter's red spot has been shrinking for a number of years.
Okay.
And you can significantly see how much it has shrunk through. If you take a look at some of the earlier photos,
yeah.
It has substantially decreased. From where it was in the 90s in particular.
Yeah.
And it's really interesting. And they're saying it's never going to go away because it's just too big a storm. But
maybe not in another few hundred years.
Well, yeah, but
I remember Uranus had a storm. Neptune had a storm like that, and it dissipated, and I think Saturn had its storms dissipate. Mm-hmm. But Jupiter's is fed by its location.
Sure.
And
it's also
fed. maybe it'll still go away at some point.
Well, it's affected a little bit by the magnetic pole in the middle, by the way, as I understand. So that may have a little bit to do with it, the activation of it.
I didn't have as much success on
would you try to shoot Saturn?
Yeah, or even some of these other ones. Here's is this finals? Okay. So here, Adrian, that's the regular. And
that's the regular photo.
Noise. I can see the difference. It probably Webex is probably making it so you probably can't even see any difference.
I see a difference. There's no question about it.
I'm sort of flipping back between the two.
The poles are fuzzy, and some of the small.
No, I have two images, and I'm flipping between the two. So I don't even. It's barely discernible on my end. But certain things have lots of noise, and I think the denoise is worth it. The sharpen is cool. The other two were
not so much.
Virtually free in the bundle.
I see a big difference.
But
okay, the other picture way sharper. Yeah,
with this particular image here, I mean, just
that's just that's crystal.
You've got some more feature. You got more cloud features and more things to look at on that version of your Jupiter, and that's
3-minute warning, y'all.
Okay.
I'm trying to see is that. Do you have in this picture? Is there I'm not seeing it. I was wondering if there's a picture of a moon that's above there, or just a distant star. It looks like it's a distant star on the top of it.
Yeah, there's no.
No.
Yeah, all the moons are.
Here's one with a moon. Actually, I should say a shadow.
Yeah. Okay. Yeah.
It's off sensor.
Well, let's see. That's probably not EO. That looks looks like it's probably Ganymede for the size of it.
I can't remember. I do have the date, so we can figure it out. But
yeah, it could be EO.
There's one other one that I think that I sharpened up a bit. I got rid of some noise. On that.
Yeah. That's definitely
that would
EO.
be ION Ganymede, if I'm not mistaken.
No, I think that's the shadow of EO in the middle, and that's EO itself on the outside, isn't it?
Yeah.
Is that what it is? Yeah.
Well, I think there were two.
No. Those are two. That's two. That's right. That's two shadows. Yeah. That is. This one here would probably be Ganymede, and this would be EO because EO is much closer to the.
Yes. Ganymede is off sensor. It's too far out.
Yeah. EO is about the same distance from Jupiter's surface as the moon is from us.
So we're looking forward to when Jupiter comes back.
Yeah. Attention! It is 6:30. Yeah, it is 8:39.
You're in the Pacific time zone, Diane.
Yeah, no, I'd be in Mountain Time or something like that. Yeah. So it's 8:39. So let's reconvene. Give y'all a minute to settle in, and then I will hand things over to Dr. Dale Parton to introduce tonight's speaker. Yeah.
There's Dr. Dale Parton.
You ready, Diane?
I am ready.
Okay. Well, surprise, surprise. Our speaker tonight is our own Diane Hall, our current president. She has served on the board in a number of roles over quite a number of years. It's been my pleasure to work with her on many an occasion there. She's also given many presentations to this august society, sharing both her enthusiasm and her experience with astronomy. Those of you that are avid readers of the WASP will know that she writes a column each month called The President's Point of View. And also I've enjoyed movie reviews that she fairly frequently includes in her contributions. So tonight, her topic is the Galileo mission. Diane, take it away.
Thank you, Dale. And likewise, it's been my pleasure serving with you on many aboard. All right, gang. And there we go. And you see my title screen.
Yes.
Okay. All right, the Galileo mission. So, I received a surprise present last year from my spouse and observing partner, Jonathan. A vintage t-shirt from a NASA mission that I knew little about, to be honest. And I was taken with the eye-popping highlighter Sharpie color scheme of the thing. I decided to wear it because when else but a worldwide pandemic can you wear a bright yellow t-shirt just whenever you want to? And but I wanted to wear it proudly. And in order to wear this shirt proudly, I needed to know something about Galileo. So, Galileo was the first spacecraft to orbit an outer planet, the first to deploy an entry probe into the atmosphere of an outer planet. It orbited Jupiter for almost 8 years, made close passes by all of its major moons. Its suite of 10 instruments sent back reports that allowed scientists to determine, say, that Jupiter's icy moon Europa probably has a subsurface ocean with more water than the total amount found on Earth. They also discovered that the volcanoes of the moon Io generate enough material to constantly resurface the little sulfur world. They found that the giant moon Ganymede possesses a magnetic field. And the probe went deep into the atmosphere of Jupiter, taking readings for almost an hour before crushed by the overwhelming atmospheric pressure. So Jupiter, the largest planet in our solar system, was rated in 1968 as the #1 priority for exploration by the U.S. National Resource Council's Planetary Science Decadal Survey. Of course, 1968, the U.S. is on the cusp of sending humans to the moon. Project Apollo has not yet been catastrophically defunded. And the Soviets are going great guns in what will be incredible explorations of Venus, though the US won't know the full details for quite some time. But Jupiter is cited as the thing to explore. Well, over the course of the next decade, 4 spacecraft, Pioneer 10, Pioneer 11, Voyager 1, and then Voyager 2, proceeded to fly by Jupiter and its moons. But nobody entered orbit around the planet. That was reserved for Galileo. So, like the famed astronomer that gives the mission its name, it would study Jupiter over an extended period and, uncover as many of its mysteries as possible. So Project Galileo received the green light in 1977. Now, again, this was a transitional time for the U.S. space program. The Saturn V rockets were either in museums or pieces since the wrap up of the Apollo project with Skylab and then Apollo Soyuz. The space shuttle was not yet ready to fly. So at the time that Project Galileo got the thumbs up, there was nothing available to put it aloft. But hey, plans were in the works. It was saved fairly early on from cancellation by the US Air Force. The Air Force was interested in the technology being used on Galileo that gave the craft the potential for evasive maneuvers and the specs that equipped it to survive intense radiation. It was a peak of the Cold War. They were interested in doing things that would survive or outwit or outgun the Soviets. Anyway, total cost from start of planning through the end of the mission, $1.39 billion, with an additional contribution from international entities, another $110 million. And it was an international project. More than 100 scientists from 6 nations, that being the US, Great Britain, Germany, France, Canada, and Sweden, came together to carry out the experiments. So, what does it consist of? Well, you can see here there's the orbiter with the long boom. So this orbiter was 17 feet high. The boom with the magnetometer attached was 36 feet. And the full apparatus weighed almost 5,000 pounds, with 2,000 of that simply being fuel. And it was powered by a pair of radioisotope thermoelectric generators, or RTGs. More on that in a bit, but the upshot is it had 570 watts of power to send a craft to Jupiter. The instrument suite, as I said, 10 pieces. So we have a solid state imaging camera, several different kinds of spectrometers, one for near infrared, one for ultraviolet, a photopolarimeter radiometer, a magnetometer, an energetic particles detector, a dust detector, a heavy ion counter, and a couple of gizmos to investigate plasma. So nice suite of instruments there. And here's some close-ups of the heavy ion counter at the top left, the solid state imager at the bottom left, and the, what's the other one here? Oh yeah, the ultraviolet spectrometer. So several different pieces of the equipment suite. As for the probe, it was based on the very design of the large central probe, seen in the picture here, of the Pioneer Venus multi-probe that was referenced earlier in the news report, whose data is still being looked over today. So that was a gizmo that had a large probe accompanied by smaller daughter probes, and they all went into the atmosphere at Venus. This was one probe, 50 inches in diameter, 3 feet high, weighed 750 pounds, and had a suite of 6 instruments, including another mass spectrometer, radio emission instrument, and some stuff to test the atmosphere. And here's a shot of the probe deploying its parachute in a test tunnel here on Earth. For those of you not familiar with the name Galileo, of course, this is the Italian astronomer, polymath, not technically a Renaissance man because it was a bit late for the Renaissance, but a guy who did a lot of things, ranging from getting himself in hot water with the Catholic Church to allegedly dropping balls off the side of the Tower of Pisa. Galileo Galilei. Arguably the first scientist in the sense that we think of a modern Western scientist. He discovered the 4 largest moons around Jupiter in 1609/1610. Wrote about his findings in his publication, The Starry Messenger, where he named them for his patron, the Grand Duke of Tuscany, Cosimo de' Medici, and Cosimo's 3 younger brothers. Today we call them Io, Europa, Ganymede, and Callisto, and Galileo would not be very happy, but he is very dead, so we don't care. But hey, he did a lot of good work, so we've named the craft after him. So, how do we get to Jupiter? As I said, at the time that Galileo got the green light, there was no way of getting to Jupiter because nothing had been built yet. Early plans for the mission called for a direct ascent to Jupiter. It would have lifted off Earth using a fascinating combination of the familiar glider-like space shuttle orbiter and the upper stage of the ambitious Centaur rocket. This was a project, again, supported by the U.S. Air Force. The Air Force had its fingers in this project for quite a while. Space shuttles Challenger and Atlantis were both modified to be used with the Centaur integrated support system. But when Challenger had a fatal accident, killing the crew and putting a halt to the shuttle program in 1986, the conditions under which the space shuttle program restarted caused numerous programs, including the Centaur shuttle union, to get scrapped. It was no longer something anybody was willing to entertain, and that meant a direct flight to Jupiter was now impossible. So a new flight plan was developed using flybys of Venus and Earth to provide gravity assists to help the spacecraft on its way to Jupiter. Although this method greatly increased the time that it would take Galileo to get to Jupiter, it provided numerous opportunities for the spacecraft to pass by and have a look at other objects. The idea that it could swing by an asteroid en route to Jupiter was always part of the plan, but with the gravity assist method, it could hit 2 asteroids, and Venus, and Earth, and the Moon. And so this became known as the VEGA, V-E-E-G-A, Venus Earth Gravity Assist. Now, in addition to the delays caused by the time that it took the shuttle program to reboot following the loss of Challenger, anti-nuclear groups got concerned over those RTGs, which used plutonium. They became concerned over what they viewed was an unacceptable risk to the public from a couple of plutonium reactors in a spacecraft, when it was very well demonstrated that spacecraft might blow up. So earlier spacecraft, including the 2 Voyager missions, had used plutonium without incident. But since then, a couple of things had happened. So this wreckage here on screen is the remains of the Soviet Union's nuclear-powered Cosmos 954, which crashed into Canada in 1978 and made a mess. And while it was not nuclear-powered, it was very hard for people to forget about Challenger. How could you? So that raised public awareness about spacecraft failures, and nobody wanted a spacecraft failure to turn into a mushroom cloud. It wouldn't, but it wasn't unreasonable. No RTGs had ever been used in a non-orbital buzz swing past the Earth at close range and extremely high speed, which is what the gravity assist using Earth was going to entail. So this created a remote but real possibility that if something went wrong during one of those flybys, Galileo's entire load of plutonium might be dispersed in the atmosphere of Earth, which was an outcome that nobody wanted. So even Carl Sagan, who was a very strong supporter of the mission, as one might expect, said in 1989, "There's nothing absurd about either side of this argument." Now, after Challenger, study considered additional shielding, but rejected it because that increased the cost, and it increased the complexity, and that increased the overall risk. So you're basically moving risks around from one category to the other, while simultaneously increasing the chance that the whole thing might come back down to Earth anyway, which again, nobody wanted. So ultimately, the court battles failed to keep Galileo from lifting off. 18 October 1989, Kennedy Space Center, Florida. The mission launched aboard Space Shuttle Atlantis on STS-34. Here you can see the spacecraft being deployed from the shuttle's massive cargo bay. You can see the Galileo mission script there on the left-hand side of the craft. It's in this sort of a italic font. Same logo that's on my t-shirt. STS-34 was one of the reduced crew launches that happened during the return to space period, where shuttles were getting their wings back following Challenger. But you might recognize a couple of names off the crew. Shannon Lucid, one of the pioneering women joining the astronaut corps. Franklin Chung Diaz, who's gone on to be a space advocate for some of the private companies. So a couple of familiar names there. Pretty short mission, only 5 days. Of course, this is well before the ISS, so they went up to deploy a satellite, and they did. Here is Galileo floating free into space after Atlantis waved it goodbye. Now, it did have a little bit of Earth science to do, so during one of the Earth flybys, it looked for chlorophyll, looked to see if you could detect certain ingredients for life, like the absorption lines from chlorophyll contained within plants that do photosynthesis. And it did. It could detect them from space. This was one of the things that Carl Sagan had been interested in. So we're off and doing flybys. Here's a lovely blue-hued picture of Venus. Galileo made its closest approach to Venus on the 15th of February, 1990. Took this picture 5 days later from 2.7 million kilometers away. Now, the camera malfunctioned. It started just taking pictures for 5 hours straight. Snapped away uncontrollably, didn't cause any harm to the overall mission. It was basically like the camera was acting. It took the pictures it needed to take, which was 16, and then just kept going, acting like a malfunctioning camera with no film. So that was annoying, but they were able to do the troubleshooting, and again, no harm done to the overall mission. It was just the first glitch in what would prove to be a pretty glitchy mission. So on the flybys of Earth and the Moon, Galileo took that true color image of the Moon, which is pretty pixelated, on its first Earth flyby, December 9th of 1990. The false color mosaics are from the second flyby, December 7th, 1992. So Galileo, found clearer views of the lunar far side, good views of the north and the polar regions. And since it had the multispectral suite of instruments, near infrared, visual light, ultraviolet, scientists were pretty happy to get their hands on that. There's still a lot. This was well before the LRO. There's still a lot we didn't know about the moon's topography. Unfortunately, we get to the next, much more serious glitch. Galileo's high-gain antenna failed to fully deploy after its first flyby of Earth. The antenna had 18 ribs, kind of like an umbrella, but when the driver motor started, everything was supposed to pop out of a cup that held the tips, but only 15 did. And so you had the antenna looking like a half-open umbrella. Investigators concluded that during the 4.5 years that Galileo spent in storage, during the pause in the program following the Challenger disaster, the lubricant dried up and nobody thought to grease it. Moral: experiments probably shouldn't sit around for 4.5 years unattended. But wonky antenna or no, completed the flybys of Earth and the Moon and managed to wedge in a flyby and imaging of an asteroid named Gaspra. Gaspra is named for a Crimean spa town, beloved of its Russian discoverer. It is a tiny little thing on the inner edge of the asteroid belt. It's got a mean diameter of only 12.2 kilometers, and the surface area is about the size of, say, the territory of Guam or the city of Hong Kong. It's little. But it was the first asteroid ever visited by a spacecraft and imaged. 57 images were returned to Earth, the closest taken from about 5,300 kilometers away, and about 80% of its surface was ultimately imaged during the flybys. So at the time that Galileo set out for Gaspra, its whereabouts could only be pinned down to with an uncertainty of about 200 kilometers. That's kind of a problem when you're traveling at high speed through space. So to reduce the uncertainty, not just to avoid a collision, but so that the pictures could actually be taken successfully, a pioneering optical navigation was implemented by the spacecraft team. Now, this is the kind of stuff the Air Force was interested in. But this reduced the uncertainty of Gaspar's position so that the spacecraft was able to take a lot of good pictures from about, again, 5,300 kilometers away. The pointing was accurate enough, and the camera took a giant 51 image mosaic, which turned out pretty nice. After Gaspra, the next target was the asteroid Ida. Some of y'all may have heard of it. It's significantly larger than Gaspra, the mean radius of 15.7 kilometers, and your typical Greek mythology name that early minor planets and many other bodies in the solar system have. Ida turned out to be densely cratered. One of the most densely cratered bodies yet explored in the solar system, even to this day. Now, Galileo was able to determine its composition. It's an ordinary chondrite, which is the most common type of meteorite to land on Earth, and it's part of the Coronis family of asteroids, which all originated from a collision between Coronis, the parent body, and something else about 2 billion years ago. So here we've got a size comparison of Gaspra, Eros, another fairly well-known asteroid, Ida, you can see it's quite a bit larger, and then Vesta, the protoplanet, dwarf planet Ceres, and Mars. So yes, Galileo visited a couple of space potatoes. And then it was on to Jupiter, where Galileo's arrival was in time for an incredible show. These are impacts of comet fragments into Jupiter observed while en route in July of 1994, the first, and thus far only, direct observation of a comet colliding with a planet's atmosphere. This, of course, is the famous Shoemaker-Levy 9. Amazing timing, something that the people who thought up Galileo in 1977 never could have planned for. And after several years of looping around the inner solar system, on the 7th of December, 1995, Galileo reached its primary destination. The main part of the craft was to insert itself into orbit, and the probe was set to descend into the Jovian clouds, which it did. Entered, opened up the parachute, went down, and did science all the way down until 61.4 minutes after entry. It got crushed by the incredible pressure. We're talking almost 23 times the atmospheric pressure here on Earth. The data was transmitted up to the main spacecraft and then back to Earth. Data indicated intense radiation belt about 50,000 kilometers above Jupiter's cloud tops. Very few organic compounds, surprisingly little water, surprisingly little helium, and incredible winds, 640 meters per second. So that's half a mile per second. It was later transpired the probe entered in an unusually dry area of Jupiter. The rest of Jupiter has more water vapor, more helium, more lightning. And of course, there was a glitch. The atmospheric probe deployed its parachute 53 seconds later than anticipated, resulting in a small loss of upper atmospheric readings. Not too big of a deal when you're active for nearly an hour, but they missed a minute. They had wiring problems with the accelerometer. The accelerometer didn't trigger, the parachute didn't open quite on time, but not too bad. Somewhere in between the jammed camera and the oops, our high gain antenna doesn't work in the crisis scale. So one thing that I liked about studying for Galileo is the amazing in-house NASA art that has been, produced for this mission. Definitely adds to the drama here. You've got the probe being released and the billowing clouds, and here's a real nice one of the orbiter doing its thing. So the primary mission was a 2-year orbital tour of Jupiter and its main satellites, doing science. For instance, you've got this GOPEX experiment, which managed to take several different pictures of Earth through the Jupiter clouds. The GOPEX science may be used in the future for developing downlinks for communication on other interplanetary missions. So there's still a lot of stuff that Galileo did that has the potential to pay off in future missions. And then you've got the images, like this amazing shot of a backlit Jupiter with its rings. Rings as nobody, of course, had ever seen them before. It accomplished many flybys of the moons, 7 of Io, 8 apiece of Callisto and Ganymede, 11 of Europa, resulting in this amazing pole-to-pole mosaic taken over multiple swings, and then 1 of Little Amalthea, which got interesting. The primary mission wrapped up after 2 years, but there was still juice in the plutonium generators, so mission got extended for another 2 years. It was called the Galileo Europa mission, and that was good from 1997 through the year 2000. So here is a lovely photo of, looks like textiles weaving fabric of salt deposits on the crust of Europa. After that, the Europa mission gave way to the Galileo Millennium mission, active from 2000 to 2003. During this phase, it paid a visit to tiny Amalthea, a little moon inside the orbit of the Galilean moons, the last alien moon discovered with a ground-based telescope in our solar system. So any moon between Amalthea and the satellite age just didn't happen. These 4 views of the little moon were taken with a solid-state imaging system. But again, we had a problem. About 10 minutes after the closest approach of the Amalthea flyby, Galileo stopped collecting data, shut down all of its instruments, and went into safe mode. The data had already been written to tape, but the recorder wouldn't follow commands, wouldn't play it back to ground control. So, after several weeks of troubleshooting using the identical spare recorder on the ground, they found out 3 Optec LEDs located in the motor encoder wheel weren't putting out enough light. Well, how do you deal with LEDs that aren't emitting enough light when the LEDs are in orbit around Jupiter? They did something incredibly clever. They passed current through the LED for hours at a time to heat them up to basically melt out defects in the crystalline lattice, increasing the LED output every time. So they did these annealing cycles for hours and hours, hundreds of hours at a time, in order to get the recorder to operate first for an hour, then more, and then ultimately they got all the data from the Amalthea flyby. So that's one of those, maybe it's not as dramatic as the Apollo 13 guys rigging up canisters to prevent themselves from suffocating to death, but still very cool. And then all good things come to an end. It had been a tough time out there. Years of Jupiter's intense radiation was kind of cooking the spacecraft, and the fuel supply was finally running out in the early 2000s. And Galileo had never been sterilized. So it was all filled with whatever kind of earth bacteria and viruses and whatnot survive a trip through the asteroid belt and Jupiter's radiation. It might have been sterilized by the radiation encountered there, but nobody knew. So the plan became, rather than risk it contaminating one of the moons, just crash it into Jupiter, send it right into the cloud tops, following the fate of the probe, and we're done. So Jupiter embraced Galileo one last time on September 21st, 2003. Speed of entry, 47 kilometers a second. It'd be like traveling from the New York City to Los Angeles in 82 seconds. And that might have been the end, but we haven't celebrated everything that Galileo learned yet. So here's a short list of cool stuff that we now know thanks to this mission. Number one, the nature of the Jovian rings. So Jupiter has little rings, very different from the beautiful icy rings of Saturn. They're formed by dust, kicked up by interplanetary meteoroids that get intercepted by the inner moons, not the Galilean moons, but the little moons inside the Galilean moons, and just get mashed up and form a tenuous halo ring and two even more tenuous gossamer rings. So you can see some of that ring structure in this photograph, and you can see the notch carved in the rings by one of those little shepherd moons, Metis. We learned a ton about the Galilean moons, including that Europa, Ganymede, and Callisto all have a thin atmospheric layer called a surface-bound exosphere. Nothing, though, is quite like what we found about Io. Complex plasma interactions in its atmosphere, currents, coupling to Jupiter, in addition to the way that the stuff that the volcanoes cough up replenishes and refinishes the surface. So Io proved fascinating. Galileo determined that the volcanic activity may be 100 times greater than what's found on Earth, with a heat and a frequency of eruption that probably looks a lot like Earth looked in its own infancy. Now, while the volcanic activity is bonkers, Galileo also ruled out magnetic activity, even though the little moon does have an iron core. So it's got the volcanism, it does not have a magnetic field, does not have magnetism. We found a lot about Jupiter's atmosphere. You know, it measured what's in it, it measured the pressure. One thing that was interesting was that the abundances of various elements were different than what is known of the sun, indicating that Jupiter's atmosphere has evolved in some fashion since the planet's formation. So that's pretty cool. And of course, now Jupiter is famous for the electromagnetic activity in its clouds, but Galileo's probe discovered Jupiter's got thunderstorms, many times larger than Earth. So here's two images taken 75 minutes apart in visual light. Not bit of false color here, it wasn't that red, but visual light, showing lightning storms in the night side of Jupiter and clouds lit up by reflected light from Io. I think that's pretty cool. Want a magnetic moon, you want Ganymede. It's the first moon known to possess a magnetic field, and it's unique in having its own tiny little magnetosphere carved inside Jupiter's massive magnetic field. So, how does it get that? Well, it's generated the same way that the Earth magnetic field is. It's got conducting material sloshing around in the interior. And we will talk about that one bullet point from now. First moon around an asteroid. Sharp-eyed viewers may have noticed a little thing called dactyl tucked into the big picture of Ida earlier. Tiny dactyl orbits Ida, and Galileo discovered her. This picture taken by the high-res camera from about 3,900 kilometers away. When Dactyl was separated from Ida by about 90 kilometers, They probably originate from the same parent body, the Coronis debris field. Dactyl is 1/20th the size of its sibling. It's a mere 1.4 kilometers across. It's tiny. So the fact that we have a picture this good is pretty cool. Now, mentioned what's going on under the surface of Ganymede. The magnetic data from Galileo indicate that Ganymede and Callisto are extremely differentiated under the crust. They've got liquid saltwater layers, and then so Callisto is very icy. It's got ice, salt water, more ice, rock with ice, and then a rock and dead metal core. Ganymede, though, it's got the ice, the ocean, the ice, and then a rocky mantle and a liquid outer core with a solid inner core. Again, very reminiscent of Earth, except we have a surface ocean. And that, of course, is what makes the magnetic field possible. It's got that liquid core spinning around, generating the magnetic field, just like us. And then the most exciting finding, and the one that determined the manner of Galileo's demise, global ocean of liquid water under the icy surface of Europa vaulted Europa to the top of the list for places where we might seek out alien life in our solar system. And of course, a bunch of other stuff, like being the first spacecraft to operate in a giant magnetosphere long enough to study it. All kinds of amazing pictures. Like this is one of the images of Callisto, craters upon craters. 8 years is a long time to take a lot of cool readings, images, everything like that. Galileo has been gone for nearly 2 decades, but to this day, scientists are still gleaning information from the data it collected. And of course, it has been followed up by the Juno mission, currently orbiting Jupiter, which is picking up where Galileo left off on many of its observations of the planet's internal structure. We've got 2 missions in the works to the moons, the upcoming Europa Clipper, a NASA mission that will expand on what Galileo accomplished in studying the little icy ocean world. And the European Space Agency has JUICE, the Jupiter Icy Moons Explorer, in the works. That said, I don't think any other mission is ever going to top the fabulous early 90s style of that highlighter yellow t-shirt. And if you really want to celebrate Galileo in style, you can still get sealed Hot Wheels action packs of Galileo and its probe and a properly unfurled high gain antenna. Thank you very much. Totally open for questions.
I have one, Diane.
Sure.
I vaguely recall from when this mission happened that, as you mentioned, the main antenna only partly opened. My recollection is there was a small little baby antenna that didn't have to open that could only send and receive a very weak signal, and that's the antenna they actually used for communication, not a partially opened antenna. Do you know which is actually correct?
So most of the information that I found from about the mission was actually straight up from NASA and JPL, which have really cool websites that were preserved. They did mention the low gain antenna being used as a go-between, but given that that was kind of the high point of drama, I expected a lot more juicy stuff than I found. So yes, they used the low gain antenna that previously hadn't really factored into anybody's expectations. And they could only get, like half of what they needed to out of the antenna. They tried quite a few things, shaking it, pulsing it, and they only got to move it just a little bitty bit. So yeah, that was a pretty big goof up. But you're right, they did have the low gain antenna as a backup, thankfully.
Yeah, my recollection, for what it's worth, is it had a ultra low data rate.
Oh yeah.
And so they had these beautiful pictures being taken, but it was too much data to send through this low gain antenna. So they invented, I think, JPEG or something like that, some way of compressing video
Yes.
files.
They used it. Yep, they used data compression to increase the. First, it was like 160 bits a second, and then they were able to get it up to I think 1,000 bits a second, which actually is pretty impressive from space.
Diane,
Yes.
I was wondering, I learned something tonight that it's Ganymede.
Oh,
Ganymede. Tell me, I would like to know
no,
because
I mean, it's the whole, like, some of us learn from listening to British programs, some of us
Sure.
learn from listening to American programs. Like I've taken to using Ganymede and EO. I
Okay.
grew up saying Ganymede and IO.
Yeah, I said
Pretty
it,
cool.
EO, right, is how I had
Yeah.
learned it also, but
Yeah.
that's very cool that I heard it as Ganymede. I like it. I'll use
Yeah.
it. I like it. Super. Great presentation, which there was never any doubt, Diane, of course.
Thank you. Any more questions? I learned a lot researching this because even though it's a really cool mission, it feels like it kind of went down the memory hole. I had assumed that a lot of the things that Galileo discovered were actually discovered by like Voyager 1 and 2.
Well, let's thank
very
our
good
speaker.
presentation.
Thank you,
you.
Diane.
Yeah, I really like the engineers coming up with solutions, like warming up the LEDs.
The LED thing was amazing. That is one of the weirdest
That's-
MacGyver tricks I've ever read about.
Yeah, that's ingenuity, true ingenuity.
I guess my question about that, I used to work on LEDs when I was a grad student. And clearly they validated that those LEDs worked before they launched the mission. So I'm suspecting that what happened is radiation produced defects that degraded the LED's light output. But by heating the LEDs up, not to the melting point that would ruin them, but just heating them up enough, it annealed out enough of the radiation damage to make them work again. But pretty slick.
Yeah, really slick. And I agree with you. My assumption when reading it was that it must have been cooked by the, incredible radiation of the Jupiter system. But I didn't see, maybe they were being diplomatic, but I didn't see anybody laying the blame at anything other than, hey, they didn't work the way that they were supposed to.
I got another fast question for you.
Sure.
How long was the Galileo mission around Jupiter? I don't recall.
8 years.
8 years.
1995 to 2003.
Now, how much damage do they know that it took because of the radiant energy of Jupiter? Is there any decrease in the ability to do what it was doing because of radiation they would blame?
One thing that I read was that like the final 2 years it was really tenuous, but I didn't find any that was one source that I couldn't find any additional verification for. So apparently there was a 2-year stretch where it was really starting to show.
Okay.
But yeah, I again, I can be wrong, but I vaguely remember that in the last year or two they sent, they'd got most of what they were going to get out of the spacecraft, and they were tired of the low data rate coming from it. So they started sending it into higher radiation zones.
Positions, yeah, okay.
Makes sense.
Yeah, the extended Millennium mission was where it really started to get cooked.
Okay, that's very cool. Very cool.
I'm looking at a circuit that involves infrared LED and infrared sensor. And the problem I'm having with it is the infrared sensor works fine. It's the LED, even though there's current flow through it, for some reason it's just not generating enough LED to bounce off of a surface within 12 inches for the receiver to receive. So I might look into applying what I've learned today
Cool.
to my project. I don't know.
Yeah,
but
cool. Worth trying.
I ordered an infrared sensor card that you can hold in front of an infrared emitting diode to see if we're getting anything. But the voltage and current flow through it is fine. So I'm bewildered why the receiver is not receiving it. But it can receive the infrared from like a unshielded fluorescent light.
Hmm.
You know, so
That's neat.
baffled by it. But okay,
Cool.
thanks.
Yeah. All right, gang. Well, we're basically at 9:30, our customary time for this Thursday meeting to wrap up. So I'll happily entertain any other questions. Otherwise, we'll let you go, and we'll see you at the open house on the 4th Saturday.
Good night, all.
Night, y'all.
Good night.
Cheers.
Good night, everybody.
Good night.
What?
Diane, do you see that letter that I wrote to Kay?
That was pretty intense, Kat.
I mean, I was really kind to her, but
It was
know,
still intense.
yeah, well, it took them 2 months to send me a letter, which I thought was hilarious. But it was cool.